So let's go back to the exercise I asked you to do last time. So these are those simple exercise. So let's take a look at the first one. So it's trying to land on a ship deck which is drifting south. So when you say that the ship drifting south, that means it is relative to ground. Relative ground. So this is the velocity of ship relative to ground at 7 y0. And then at 12, the wind is blowing from the west, from the east. So that means the speed of the wind relative to the ground is 12. The CQC is it means the ship, is it? Helicopter descending at 5 meters per second. So that means this is the velocity of the helicopter relative to the ship. So find the velocity of the helicopter relative to the water and air. So helicopter relative to water and relative to air. So this is the velocity of the helicopter relative to water and relative to the just a second. The ground here, the ground here, I mean the water. But this is the wind, okay, this is the wind. Sorry, just a second. So, the ground is it means the water. Sorry, the ground means the air. It doesn't say there's a, sorry, the ground means the ship means the water. If sorry, yeah. Because the ship deck is drifting, it doesn't say that the ship is moving. So it's drifting because of the water. So therefore, it should be the helicopter relative to the water. Sorry, the water, it means the ship. And the helicopter relative to the wind, that means the air. So therefore, for the first one, the answer should be this one. For a second one, just the same as this one. For a second one, so you WH, you don't have HW, you have HS, and then plus SW, is it? But you don't have SW. How can you make the SW? You can make it as SG plus GW. But how can you make the GW? You just have, sorry, you just have WG, not GW. So you need to do subtraction. So that means the answer will be 5Z0 plus 7Y0 minus 12X0. So therefore the answer is C for cat. Do you get it? But the remaining questions, they are quite simple. I think most of you get it correct. So the answer is CAD. Any questions? If no, let's move on. So let's take a look at the third one. The answer is I mean the answer there's answer in the answer there's some typo, but answer should be A, the third one. Yep. So let's take a look at this one. A long question. But this is going to find the shortest distance between the ships as the time they reaches this position. I think this is the same almost, is it the same question we have talked about last time? Have you talked about this one? Last lesson. We do, is it? Do we? I think no, is it? But we get some similar questions as the part A. So to find the shortest distance between the ships, we are using the relative motion to do it. So let me consider the motion relative to A. If you say relative to A, that means you consider A is at rest. And then it will be good. Then the velocity of B relative to A will be 2u minus the vector u. So that means it should be in somewhere here. And then you know the ship B will just move a constant velocity relative to A. Yeah. Okay, so move along a straight line like this one. And they're going to find the shortest distance. It should be here. This is the shortest distance. So you need to find this angle, and this angle theta equals to this angle theta. So you can see for this, for finding the tangent theta, psi theta, cosine theta, you can draw this triangle. There's 2, 1. The ratio is 2, 1, and then this is square root 5. Is it? So the shortest distance will be just A times psi theta. Sorry, A times cosine theta. So it will be 2 over root 5 times A. Okay, so take a look at part B. So at t is 0, the speed of A remains at u, but its direction can be adjusted. What should be the direction of ship A such that the shortest distance between the two ships is minimal? And how much is it? How much is this minimum shorter than the resultant attained in part A? So you don't know the velocity, you don't know the direction of the velocity, so what we can do is drawing a diagram. I think it's almost the same question as last time. Actually, did we talk about this question last time? Do we? So the velocity of u can be in all directions. And then somehow, I think it's really a similar question. So somehow you can draw a semicircle. And then the resultant, you are going to find the resultant velocity, which is tangent to this circle. So it will be in pointing from here to the tangent of the circle. Then you can see that right here, there's a right angle triangle. And this, sorry, I'm not writing on this. So this is a right angle triangle. If in this angle, okay, in this angle, the shape is moving at, then the distance will be the minimum. So this is the strip A. The distance is A here. So the minimum distance will be this one. The problem is how to find this angle. This angle equals to this angle, is it? So in this case, so this side is 1, this side is 2. So this side is square root 3. No, yeah. So the shortest distance will be A times cosine theta. So this will be 2 over root 3, A. Okay. But not yet finished, because it's asked you about what is the direction of the ship A. Now this is the red arrow here. This is the negative U. This is the negative U. So that means the U should be pointing somewhere here. And then you can see how it's related to the angle theta. So this is the angle theta. And this one will also be the angle theta. So that means it should the direction of the ship A should be angle theta to the horizontal. And then the theta will have the value that is arc cosine 2 over root 3. Okay. So that is the answer for the part B. We have done some questions similar. So let's move on. Now this one is a bit more complicated. So both ships are moving, and you are going to find the minimum distance between these two ships. So you are actually doing something similar, really similar. But this one will be a bit more difficult to solve. So I would consider relative to B, okay, relative to B. Then the velocity of A relative to B will be the 5 minus 12. So it will be pointing somewhere here. I hope you can recognize this is a common right angle triangle. Sorry, I think I muted the mic. Do you? Can anyone speak?
Didn't mute.
Oh, okay, here now. So this is right angle triangle. Then with the hypotenuse 13. So and then let this angle to be theta. So that means the ship A is moving along this straight line. Okay. And then you're going to find the shortest distance. So that means the shortest distance should be this one. Okay. And then how can I find it? Now you also need to you always need to find a right angle triangle. Right? So this is the right angle triangle that you need. You know the side, you know the length of the orange side. So it will be the square root 120 squared plus 25 squared by Pythagoras theorem. And then if you can find this angle, then you can then the answer will be the square root times sine phi. Is it? Then how can we find this angle phi? So this angle phi will be this angle and then minus theta. How can I find this angle? We use the arctangent 120 divided by 25 and then minus the theta. Okay. Our theta will be just the arctangent 5 divided by 12. Sorry, I think I messed it up. The upwards is 5. So it's 12 divided by 5. Okay, then you are able to solve this question. I think the answer should be B for boy. You can verify it later today. Maybe you just do it again by yourself to see you can get the answer B for boy. Okay, so these questions are quite similar to each other. I hope you really are able to finish all of them by yourself. Okay, so let's take a look at another type of question. I think this one is quite similar. Maybe I'll give you 5 minutes time. You think about it and tell me how you do it. How you do it. Now, you may write your answer on a piece of paper and then you just send a photo to me. Now, I'm not sure if this is a hint. So what you need to do is just finding the relative velocity of the lion. That will be the velocity of lion minus the 10. Then it should point towards the deer. You try to draw it and how to make the velocity of lion to be smallest if it's like that. So it will be like the 10 to the left plus the velocity of the lion. So draw the 10 first. So you add the velocity of lion such that they should be along the dotted line direction. So it can be like this, is it? So these two vectors together added together is along the direction towards deer. It can be like this, it can be like this, and you're going to find which one will be smallest. But this is how we find the relative velocity, the velocity of lion minus the velocity of deer. Then you get the velocity of lion relative deer. It must be pointing along the pointing from L to D. Do you understand this one? If not pointing from L to D, then it can't catch the deer. You still remember when we say if you're talking about the motion relative to deer, you consider the deer is at rest. So if lion can catch a deer, that means the velocity of lion relative to deer must point towards deer. And then you just move along this straight line towards deer. So then you're going to see at which angle will give you the smallest value of V. So how you do it? Then you don't know the direction, okay? Then you just write you know the formula. You just use the velocity of the lion minus the velocity of deer, and then it will become like the 10 towards left plus the velocity of lion. You don't know which direction it is, but you know the resultant direction. You don't know the direction of this velocity, but you know the resultant velocity. I'm not drawing on the screen. No, whatever. Then how can we draw it? So this is a dotted line. So I draw the 10 first. Can the velocity of lion be like this one? No, because the resultant velocity is not along the dotted line. So that means if you draw, when you draw the velocity of the lion, it should starting from the dotted line. So it can be like this, can be like this, can be like this. Can you find the one which has the smallest magnitude? Which one? It should be the one which is perpendicular to the dotted line. So right here, there is a right angle triangle here. this V will be this has a minimum value. Then you're going to find this value. How can we find it? You see there's a right angle triangle. So let this angle be theta. Then your answer will be just 10 times sine theta. But the problem is, how can we find the theta? You see that this angle theta is actually equal to this angle theta. So then you make use of the big triangle to find the angle theta. So the theta will be arctangent 100 divided by 240. Okay, then you can get the answer. I forget the answer, but is it 3.8? 3.8 meter per second. So that is the answer. Any questions here? Maybe may you tell me at which point you find this difficult? Or in which part of the solution I told you you find that it's difficult?
I don't get what the small triangle is for.
The red triangle?
Just yeah, red triangle. How do you find it?
How can I draw it? Or
Yeah, something like that.
so this is the direction of along DL, okay, along DL. So you're adding these two vectors together. So I draw the vector 10 first. So this is with the magnitude 10. So this arrow, you know the direction and also the magnitude. You don't know the direction of this vector, and also you don't know the magnitude of this vector. But what you need to know, what you know is these two vectors added together. That means the relative velocity should point along DL, along the orange line. So then when you draw the arrow, so this one is possible, is it? Because when these two add up together, it's along the line. So this one is also possible. This one is also possible. But they all have different magnitudes. And you're going to find the smallest one. How can you draw the smallest one? And actually just transform the question from physics to mathematics. That means you are finding the shortest distance from a point to a line. Is it? From a point to a line, you're finding the shortest distance. And that means it should be the line, the perpendicular line. The perpendicular one. So then you should point from here to here. And this one should be the right angle. Okay. But first of all, you need to apply relative motion if two objects are moving. If you did that, in most of the case, your answer is wrong. The second thing you need to understand is it can catch a deer, then the relative velocity should point towards deer. The third thing is you draw the diagram. And that's it. Oh. Let's move on to the next one. So you take a look at the question first. So ship A is moving at that angle, okay? At 30 km per hour. And ship B is moving at 20 km due west. sorry, is 20 kilometers due west of the ship A. And is moving with constant speed of 15.2 kilometer per hour. Find the earliest possible time the ship A can reach the ship A. Now you can see that, okay, these two objects are not moving along a straight line. Now I can do it in two different methods. So let me apply the concept of relative motion. So the B can catch A can reach A So that means if you are talking consider relative to the motion relative to B, then A, the relative velocity of A should point towards B, is it? Then the relative velocity of A relative to B, that velocity will be let me draw it. This one, and then minus the velocity of B. But you don't know the direction of the velocity of B. It doesn't tells you. Did it? No. But you just know the magnitude is 15.2. This one you know the magnitude is 30. Okay. Do you think you can do it by yourself this time? After you know the direction of the velocity B, then you find the relative velocity. And what you need to do is, after finding the relative velocity, then the time they reach, the time will be 20 kilometers per divided by the speed, the relative velocity. Okay. I'm not drawing on the screen. Do you think you're able to do it yourself? Yes or no? The result is 50-50, okay? That means at least half of. Now then velocity of A towards B, that should be this one. And then this value is 30 Then the velocity of, and then minus that velocity, and then somewhere it should be point to here, right? Such that they get along A and B. So this value is 15.2. So this is 60 degree, or this is 30 degree. This is 30 degree. The problem is, how can we find this sign? You have learned it in IGCSE. You can use the cosine law. You can use cosine law, or you can just use some simple trigonometry. So this height will be 15, is it? And this side will be 30 cosine 30 degree. So this side will be 15.2. And then this one is 15.2. Oh, then this is simple because this is also 15. So that means the relative velocity should be 15 plus 15.2. Okay. Then the time will be just 20 divided by 15 plus 15.2. Okay. Then let's take a look at another solution. So another solution, I do not consider relative motion, but for this question, it's still fine. It's still easy to do. Now, when they wish, if you say that B can reach A, it means that at a certain time, A and B have the same coordinate. That means they are they reach at the same point, is it? So if I say they have the same coordinate, so that means they have the same horizontal and vertical coordinate. So and taking and same vertical and horizontal coordinate. Same vertical and horizontal, right? So let's take a look at the same y vertical coordinate. And you can see that, okay, they are all of A and B are initially along the same horizontal line. The y coordinate is 0. You may consider it to be 0. So if you're talking about they have the same vertical coordinate, so that means they should have the same vertical velocity all the time. You think that if A is moving up, that means due north, let's say 3 meters per second. And if B is moving due north 2 meters per second, then B cannot reach the ship A or at any time, because B is always behind A all the time. So they must have the same vertical velocity. That means the velocity due north, such that they may meet each other. Okay. Then the next, so if they have the same vertical velocity, so you take a look at the velocity of ship A. The vertical velocity is 15. The horizontal, this one is 15 with 2. So that means ship B, the velocity of ship B should have the vertical component, that's 15 also. So this is 15 with 2. Then it's not difficult for you to find the horizontal component of the ship B, which also should be with 2 by using the Pythagoras theorem. So that means, okay, then it's not difficult at all now. So the time they meet should be 20 divided by 15 plus 15 root 2. Okay. Any questions here? Sorry. I think I get a mistake in calculation. It's here should be root 3, not root 2. It should be 15 root 3. Well, next time we go to the next topic about the force. Like if you don't, you really need to try spend more time on this topic, because for this topic the question is very standard. It's always something chasing something. Is it? There's not much variation for this topic. So this topic is the topic, almost the easiest topic that you can get the full mark. But later on, force is a bit difficult. I think force is much more complicated. Hello. And then the topic energy may be easier, and the topic of momentum may be easier. And then later on the topic, there's some topic that is easier. But I think I have made every concept very clear already.
What chapter?
But indeed,
What
if you're
chapters
going
is-
to study in university, then the professor will be speaking much faster. Okay, take a look at this one. So ball A is projected horizontally with the velocity 1 meter per second. And ball B is projected at the point B with some angle theta. This is 5. No, theta 3. And both in theta 3 and 2. So this one is the one I want to talk about. So do you still remember, actually in the topic 2, I've introduced this concept, I think. So in this case, ball A and B have the same acceleration. G, downwards. Now then if you consider the relative motion, then you can just ignore the acceleration. So that means both object is actually moving along a straight line. Okay, then you don't need to really consider the angle. Oh, sorry, consider the acceleration. So you just consider A is moving straight, B is moving straight. Oh, they meet at this point, and you're going to find the angle theta. Now see if you can find it by yourself. I think this one is really easier than the question. This is already the most easiest question, or almost. So you set up the equation to find angle theta. Now you send me your answer. You send me what you have done. You write it on a piece of paper and send me your answer. I really don't understand how difficult it is. So, lah. So then the time for them to reach that point will be just 10 divided by 5 sine theta. If you consider vertical motion. If you consider horizontal motion, it will be 20 divided by 5 cosine theta plus 1. It's totally fine if you are not able to solve this equation, because this is an MC. So what you could do is substitute the angle in the choices to see for which one the equation will be satisfied. So the answer will be 31.7 degrees, is it? Yeah. So therefore answer should be C for cat. Is it difficult? Yes, most of you are still form 3. You still can have the time to catch up for next year. 好啦，then we finish today 噶啦。So next time we talk about another topic about the force.
Can I ask a question?